think we should start.
Awesome. So we're right on time, so let's get started. I'll let you first introduce yourself, and then I'll get in.
Well, you already talked. You should continue talking.
So hi, everybody. My name's Amit Khandelwal. I am a principal product manager working with Microsoft. So my job description in Microsoft is to make SQL Server successful on any non-Windows platform. So when I signed up for this job, I never knew that we would ever have an opportunity like this to kind of work with Microsoft, where I would not be working on Windows, but actually would be working on Kubernetes, Linux, and all the non-Windows platform as such. So happy to share a lot of updates here in this session, but before we get into that, let me just introduce our partner here from DH2I. Over to you.
Well, thanks, Amit. My name's OJ. I am the IT guide, as you see there, meaning anything good, bad, they point at me. So it's been a pleasure working with Amit and Amit's team on putting together solutions that make your life, DBAs, admins, whatnot, easier and better. So today, I think we have a
packed agenda.
The demos. There's a lot of demos that we'll walk through and show you guys what SQL Server can do in containers.
Correct.
And how our technology combined with SQL Server make things easier and better.
So this is how we've scheduled this session. So we've basically divided this into 3 segments. The first segment, we are going to focus upon SQL Server and Kubernetes. How are we bringing both of these things together? So that is what we focus in the first segment. The second one is where, if you look and try reading this, it kind of complicates things. But to put it in very simple words, the second section is all about how you can get your SQL Server containers deployed in less than 5 steps using something called as an operator. So if you are working with Kubernetes, you might be familiar with operator, what an operator is. And we are going to talk about an operator for SQL Server that basically enables you to deploy SQL Server using the operator. And of course, this operator is developed, managed, supported by DH2I. But the SQL Server that you deploy using that operator is fully production workload ready and supported for production workloads and fully supported by Microsoft at this point of time. And the third one, what are we going to talk about the third one? And this is something that's personal favorite for OJ. So I'll let him talk about the third option.
So the third one is the ability for you to connect various environments together. So obviously, you can run your SQL Server inside container, inside Kubernetes, which we will show you how to do so, and how easily you can do so in AKS. But in this third segment or demo, we're actually going to show you how you can span that across to other cloud provider. I know Amit is here. We should be talking about Azure and Azure only, but I want to show you guys the opportunity, the flexibility, the capability that we put together so that you are not locked in or tied down to a particular environment. So you can literally just go in and out with ease.
So just to give you an example, you might have production workload today running on-prem. Think of this. You have a Kubernetes environment running on another data center somewhere else, could be on Azure, or could be on any third-party cloud service. And what if I tell you that you have an ability that without a VNet, without a firewall port configuration, you can actually bring all of this together in one single always-on availability group replica, which means your production is running on SQL and Windows on premises. You have a container running on SQL Server, which is your node B, which is a SQL Server container, let's say on Azure Kubernetes service. And on your third node, or third replica, is a SQL Server, let's say running again on containers, somewhere on a third-party cloud. And you can move your database like you would do from the Azure, from the SSMS portal that you have for the AGs, the AG dashboard. You can just move your database from Windows, SQL on Windows, to SQL on container on an Azure Kubernetes service, or you can make the third one as the primary. And all of this is possible today and is fully supported. So I'm not talking about what's going to happen in the future, but I'm actually talking about what is fully supported as of today, as of the time we are talking at this moment. So that is what we saw. So the third demo is basically the hybrid deployment, which gives you the ability to do all of this. And again, if you think all of this is going to take you hours of time to set up, you're wrong. Because when you are in the world of Kubernetes, when you are in the world of containers, we are not talking in minutes. We are talking in seconds, and probably less than 10 seconds is what we are talking here about. So that is the kind of ability, that is the kind of the agility that we are here, that we are going to discuss. Now, before I go next, let's deep dive into the first section. The first question that I always get, so I've been working with SQL Server for almost 15 years now. So I started with the support, supporting SQL Server on Windows, moved into the field, and now into the product. And I've been working with SQL Server for almost 15 years. The first question that I get when I talk about SQL Server and containers is this the same SQL Server? And the answer to that question is affirmative yes. This is the same SQL Server engine that you're used to be working with, Polybase, full text search, replication. All of that is available with the SQL Server containers that you look at. The second question, can anyone take a guess what is the second question? The second question that I get, how is the performance? Would I get the same performance? Because when I say that you can get a SQL Server instance up and running in less than 10 seconds, and it's an instance for you, go create jobs that you would want to do, run jobs like you would do on your on-premises. The second thing that they think is, if this is starting up in less than 10 seconds, is this going to give me the same performance that I'm looking from a production workload? And the answer, again, is an affirmative yes. This is going to give you the same performance. In fact, as a product group member for SQL Server on Microsoft side, our intention or the vision that we have is you have a query running on SQL Server on Windows, you have a query of SQL Server running on container. If you have the same amount of resources, again, I'm just repeating this, if you have the same amount of resources, then the query plan that gets generated for that query should be the same across Linux, Windows, containers. So the idea here is, it's the same database engine that is running, the same tools that you've been using. For example, SSMS is what you're using. You're excited about the dark mode announcements that happened for SSMS 21 preview. All of that works absolutely the same for SQL Server containers. Active Directory authentication, Entra ID authentication, all of that today works with SQL Server on Linux as we speak. And I'm going to show you in the next slide how it looks connecting to SQL Server, because someone asked me, how does the SQL Server on Linux instance look on an SSMS? And my answer was, like a SQL Server. It's nothing different. It exactly looks the same. Now, another question, the third question that gets asked, what about the updates? Do I get the CUs? Do I get the GDRs? And the answer, again, is yes. The day the CUs and GDRs are released for SQL Server on Windows, on that same day, on that same time, is container images are updated with the latest CUs, container images are updated with the latest GDR, SQL Server packages are released, RPM and Debian for VM-based deployments. All of the release cadence is in line with SQL Server on Windows. So all in all, if you want to go get started with SQL Server containers, where do you go? You can download all the container images from the mcr.microsoft.com, which is Microsoft Container Registry. It's an official Microsoft Container Registry. So you download, for example, from how you download an exe, you download an image, and once you have an image, you just get started, or you instantiate the SQL Server instance using that particular image. With that said,
but before you go on to the next one, another thing I want to add to the patching process, that's really very important, right? For those of us who have to deal with patching. Right now, if you download a new patch, you apply it to your instance, what happens if things go wrong? Is that easy to roll back? Depends, right? But with container, because the image and the patch release on the same day. You can easily spin up another container, use it, test it against whatever data that you have, and if you're satisfied, you push it through the rest of your environment. So it takes, what, seconds?
Yeah. Just to give you an example, one of the biggest banks today who run production workload on SQL Server on Linux, and I'm talking about their stock and their stock exchange, as well as some of their core banking applications, which run on SQL Server on Linux. They run or they do their functional and application testing on SQL Server. So the production is already running on Linux. Their functional and application testing is running on SQL Server on Linux. And as soon as the CU is released, they are able to test this because it takes, what, less than 15 seconds to get that box or get that instance up and running. And they have been able to reduce their application testing and performance stress testing times from days to probably from multiple weeks to probably few days. That's the kind of impact that they're driving with SQL Server running on Linux, especially for their new applications where probably you might have chosen Postgres or MySQL. Now you have an option to kind of run with SQL Server in those environments. With that said, let's just take a look. For example, if I have to tell you, okay, let's run a container and enable Active Directory authentication for SQL Server, this is how it is. This is how easy it is. There is a utility that we've released called as the AD-util, and you just download the AD-util tool on a domain-joined box, which is probably a Linux box which is already joined to a Windows domain. If it isn't, there are steps provided in Microsoft official documentation that you can follow. Once you have the server joined to the domain, you just install AD-util, run 2 commands, create a file called as keytab. Think of keytab as your file that has SPN and user information to be able to connect to the Active Directory. Provide that keytab path to SQL Server through MS SQL config. And once you do that, all you've got to do is, if this is a server where you're running SQL Server on the VM, then just start the SQL Server, install the SQL Server, start it, and Active Directory is configured. If there is another server which is not domain joined, but you want your SQL container to be joined to the domain, just copy these 3 files from this machine where you created it, bring it to the second machine where you want to run the Docker, and this one command that you see here is all that is needed to start a SQL Server instance and have it connected to the Active Directory, and that's all. Create the logins that you normally would do and get started with it. That's how simple it is. And on the right side of the screen, right side of your screen that you basically see is how it looks on SSMS, right? The first one is how it looks with the SA account connected. You should disable the SA account. Please do not use it. I did this because it was an easy way out when configuring a demo. And the second, what you see here, is an Active Directory account that I've used. I've used my Amwin account from the Contoso domain to connect to SQL Server. That's how simple it is. And I think you know the tool that I'm using here. It's the good old SSMS. That's how easy it is. Now, we've talked about containers. We've talked about the release cadence. We've talked about how the performance and everything is the same. The next thing that we want to bring into the equation, so far you've understood about SQL Server on Linux, SQL Server containers. The next thing that we are going to bring into the equation is Kubernetes. And for that, let me ask you, what is Kubernetes and why is it even needed?
So Kubernetes is a technology that developed and released by Google back in 2014. So originally, it's simply a orchestration technology or tool that allow you to manage a simple Docker container. And of course, as things move forward to today, it is a platform of choice to develop and manage large deployments of your containers, any kind of containers, right? It could be app, could be anything. And what's cool about Kubernetes is it provides the high availability inside it. So if there's a pod failure, that your app's running inside that pod, Kubernetes will notice that, will bring the pod right back up on your behalf. So then, it leading me to why is it important, and what SQL Server has to do anything with Kubernetes.
Yes, and that is where I want to bring these two components together in this slide. SQL Server instance that you're used to run on a VM, and when you run it on a VM, you call it as an instance. It's a process that you can look at the task manager, it's running. When you run SQL Server as a container on Kubernetes, we have this logical formation called as a pod, inside which you can have multiple containers. In this case, I'm just showing you one of the container being SQL Server, and you will see that we are attaching it with a persistent volume. So there is something called a storage class, there's persistent volume claims, persistent volume. I'm going to show you that in the next demo that I want to immediately get to, where I'm going to go into the details of it. But the idea here is this container is connected to a persistent volume, which means if your SQL Server container goes down, or you stop your SQL Server pod and it comes up on another worker node, it would still have the same databases that you have. If I have to give you an analogy, think of this as the Windows Server failover clustering, right? If the instance goes down, it brings up the instance back up again on another server. But if you need RPO, RTO, for a database, you'll also have an AG on top of a SQL Server instance, right? So AG provides the database level failover, if I may say so, and the FCI, which is running, the failover cluster instance which is running, is giving you the instance level. Here, the same concept, you have a persistent volume, which is a shared storage, as you can see, and you have multiple worker nodes, and Kubernetes is taking care, so when the resource goes down, automatically the pod comes up on another node, connects back to the persistent volume, gets you back connected, and gets you back up and running. That's exactly what it does. Now, you might ask, if all of this is taken care by Kubernetes, then why high availability? What should I basically do with that? Hold on to that question, because what I want to do now is just show you a quick demo of how easy it is to get started with a Kubernetes cluster. So in this demo, what are we going to do? We are just going to create a Kubernetes cluster. We are then going to deploy SQL Server on top of this cluster. And then we are just going to see how long it takes for us to get all of this done in this next demo. I really wanted to show you this live. If you guys have time, walk over to Microsoft booth. You'll find me there, or the DH2I, you might find me there as well. I will show you this to you real time, how easy it is. So with that said, let's just start with this demo. Yeah, I'm just logging into using AZCLI, I'm just logging into my Azure credentials. Then I create a Kubernetes cluster. I hope you can all see this. I create a Kubernetes cluster. Once I create the Kubernetes cluster, I'm connected to it. And with AZCLI, you get the kubectl, by the way. So when you have AZCLI installed, you also have kubectl. And you can see I have none of the resources created yet. Now, I'm first creating a persistent storage that I'm going to use. So this storage YAML is basically creating that persistent storage that you saw in the previous slide. What does it have? It basically says, take some amount of storage. What is that some amount? It's about 8 GB of storage from the Azure disk, which is added to my Azure Kubernetes service. And once you have that, once the persistent storage is created, I need a secret to be created. What does the secret contain? Of course, SA password. And should you use a password like what I've used? No, you shouldn't. And once you have the secret created, it basically has now the SA credentials. So the Kubernetes will deploy SQL Server and configure this SA as the account with that. And my Kubernetes cluster deployment has started with the command that I ran. What am I doing in this deployment? I'm just deploying one SQL Server instance. The name of the instance is MS SQL INST, very innovative. And then the image that I'm using is the latest 2022 image. That is the image I'm using here. The SA password is coming from the secret that I've provided. And this, the persistent storage, so all the data that goes into where opt MS SQL is persistent, which means if the container goes down, my storage would still be up. So I couldn't even explain all of this at this speed. And within that, in about 56 seconds, I had a SQL Server instance up and running with this. And connecting to it is as simple as open SSMS, use the service that you created, and use the IP address, connect to your SQL Server instance, and get started with it. The agent might look disabled here, but you can always enable the agent service like you would do. But instead of doing it through services, here you do it through MS SQL config. That's all it took me to get started with the SQL Server agent. Now, I am going to delete the pod here. Now I'm going to show you what it means to provide high availability. I'm deleting a SQL Server pod here, which means the SQL Server is now deleted, which means if you had applications connecting to it, they are now not going to be able to connect. And you can see the container creation has started in the background. I just deleted it. As soon as the delete happened, Kubernetes understood that replica has gone down. I need to bring that up. It started working on that. You can see the container creation happening. So your application is down for 9 seconds, 10, 15, 20, 25. Your application is still down. Your application is still down. 36 seconds. So it took about 36 seconds for SQL Server to come up, and this is an empty SQL Server. When I say empty, it does not have a user database yet attached to it. If it had a user database attached to it, the recovery process will happen. All of that is going to happen. So it took about 1 minute or so for the entire system to be down, but within 1 minute, it was up. Imagine if this would have been a node level issue, the persistent storage would have also moved, which means another minute or two added to it. So your application was down for almost 5 minutes or 4 minutes. Is that acceptable based on the current production standards? I'm assuming no is the answer. It isn't accepted, and that's where the H2I comes in to provide you the recovery time objective and recovery point objective standards of a database where if things go down, within few seconds it should be up and should get you running. And that is why just having Kubernetes and SQL Server is not good enough. You still have to have the same high availability, the business continuity features that you have, which is always on availability group, giving you database level high availability, and SQL Server taking, the Kubernetes taking care of the instance level high availability. And that's where DH2I comes in, where they have a clustering stack. So think of it like this. On Windows, if I have a high availability and I need an automatic failover as a feature, I need WSFC or Windows Server Failover Cluster to be working there. The same analogy works here as well. You need a clustering stack that can identify, that can work on a Kubernetes environment, can work on a container which is running on a VM or a physical box on Windows, on Linux, on containers, anywhere of your choice. And that's where DH2I comes in with DX Enterprise. And yep. I would let you talk now.
Thank you. Good spiel on the clustering technology. Like you all know, to have HA, you need clustering. That's very much it. That's the bottom line. Some sort of the clustering that allows you to move things around, bring the nodes up when another node down, right? So DX Enterprise is a lightweight clustering technology. It's not based on WSFC or pacemaker. It is its own clustering tech. It's lightweight. So the first thing to keep in mind is very, very lightweight. How small, how big is the package? 80 megs, I believe, for the download. And in containers, pretty small. Yeah. Way too small to count. But the key thing about DX Enterprise here is it provides HA for your instance at instance level or your AG. So it does both, not just at instance level, but also at the AG level. So for those of you who need the database level or to meet your SLA for your application at the database level, DX Enterprise can do that for you. Another thing about DX Enterprise is that it can run on top of Windows, Linux, in and out of containers.
So wherever you can imagine running SQL, you can imagine running with DX Enterprise. So it works on Windows, as you can see. SQL on Red Hat Enterprise RHELs, you can get there. SQL on SLES, you can get there. SQL on containers, you can get there. Yep. So wherever SQL is there, they have their clustering tech.
So basically, you only need a single clustering tag that allows you to really run on any platform of your choice at any time. And within the technology itself, we also introduced what I call a zero trust network access tunnels. It's allowed the replicas or the nodes or the members to talk to each other directly and privately. That is actually one of the coolest things, right? Earlier, and Michaela hinted, if you need to join one cluster or one group of nodes to another group of nodes, you would need something like a VPN or a dedicated network and or open up your ports for your apps to communicate. Now, our tunnels doesn't require you to have VPN. It does not require you to tweak your firewalls or whatever network policy that you have to open up any ports for your SQL Server replicas to talk to each other. The tunnels will get created dynamically on demand. So, and we can dive into that a little bit more down in the demo here. So then, when it comes to containers, there's two types of, or two models really, of containers that you can do. One is to create what I call a single bundle image. You take your SQL Server, you take your DX Enterprise, combine them into a single image, and then you deploy it in your environment. Another way to do it, and we believe this would be the recommended way for all of us, starting now, if you start getting into the containers, is to do things what they call in a sidecar environment. So you have a single pod, instead of having a single image for that pod, now you have a single pod with multiple containers that run side by side. That's what I call sidecar type container deployment. So with that, you would have DXE running its own container, the SQL Server running its own container, and perhaps you have customized apps that you need to run along with your SQL Server. You can also put it in there too. So then you have a single pod that may have more than two containers running inside it.
So think about this in this fashion. So you have your container, you have your high availability stack, again running as a container, and let's say you have an application that everyone's talking about AI, so let's put AI in here. So you have an AI-based application where you have your models running as a container. You could put that also in that same pod, which means now you're bringing your data closer to your AI models and being able to talk without a problem because you have one single pod, 3 containers running on top of it, and you can just have them work together. And if something goes wrong with any of these containers, it just takes the container down, not the SQL Server, high availability stack, and everything. If you do a custom image, you're basically running a single container with all these processes there. So if one has a problem, it has the ability to take the entire container down. So you see the security benefit as well here, right? You're kind of giving a compartment for every process and application to run within itself.
And when it comes to deploying them, right? So we have a quick chart here that can show the ease of use or ease of deployment. You start at the very bottom, build your own image, deploy that image, everything's custom, and you can do it however you see fit.
We did the manual script deployment in the past, in the last demo, right? I created a deployment YAML, which is almost like 40 lines of YAML file that I've written. Not very complex, but still a complex thing to write. I did the manual deployment. Then there is this Helm chart that you can just call it like an operator. Think of it. Give me an example for this. Think of it as
a script.
Yeah, a simple script, a batch script that you can just call, and it does all of this. All you have to provide the batch script is the variables. What is your instance name? What is this queue? How many CPUs do you want it to use? How much is the memory limit that you want to give? For how many instances do you want to deploy? All of that information. That's what a Helm chart would do for you. What is an operator?
Operator is, think of it as a manager, orchestrator within the Kubernetes space. It's take care of automating your deployments so that you can actually scale, right? You want something that allows you to scale. If you only deploy a single container, you know what? This doesn't really do that for you. Just do it to Docker engine. Do it on the top Docker engine, and you'll be done. But if you need the ability to scale, then the operator will streamline that process for you. So Kube operators is simply an operator, an orchestrator, manager for Kubernetes clusters. And then, of course, when we talk about Kube and operators, the HDI introduced the DX operator. So it is an operator that is designed specifically to handle SQL Server AG inside Kubernetes. For, once again, streamline the whole process. If you guys are doing the AG today, you know that you have to start with your primary, right? You have to move or make sure that the search from the primary got to be replicated across all your secondary before you can join that secondary into your AG. All of that takes time and work to get done. And with the operator, all of that can be streamlined and done for you.
So just to reiterate one more important point, the DX operator today is developed and supported by DH2I, but the SQL Server instances that you deploy using DX operator is fully supported by Microsoft. So this is the plain old SQL Server that you're used to, now just coming in a new format where you can run it as a container, which can be pulled by the DX operator to kind of tell you what image. And by the way, you have a choice. Yep. You want to run on one environment, you want to run SQL Server 2019. I don't know why, but you still would want to run. So you would run SQL 2019. Another environment, you would run SQL 22, or let's say SQL 22 with CU12, and another one with SQL 22 CU14. You can change the image that you want. So we've been publishing the container images for SQL Server starting 2017. So 2017 was the first version where we supported this, and we've been publishing container images starting 2017 CU1 to 2022 CU16, which was published last. So all these container images are available. Your choice, what you want to pick and what you want to run. We've seen customers doing this because they would want to run regression testing, performance stress, or A/B testing, anything that they would want to do against multiple different versions. This is a possibility today in few seconds that you can have your environment set up. And with the operator, it makes it so easy that all you've got to do is tell the tag or the container version that you want to run, the SKUs, how many replicas, what are the CPU limits, and if you have your own custom application that you want to bring in, because that's what you would do with CI/CD, where you would have an entire pipeline that you would want to run with that instance, you could do that as well. So you can bring your own custom applications to the operator and ask the operator to deploy that wherever you are pulling this.
Absolutely. That is truly the strength of the operator, right? It streamlines your deployment in scale. Really, that's what it's really there for. So with the operator, there is what they call a custom resource. Think of it like another config file for the operators to execute. So this is where you were telling the operator, like, I want SQL Server, I want this app, I want that app, or whatever that may be. And you stick it inside a YAML file. Once again, it's usually just a config file that you need to define. And we'll show you how easy it is to configure the entire cluster with a single YAML file.
Perfect. So you've seen the manual deployment. You know what? We've been doing a lot of talking. So let's do a demo here. And unfortunately, even when the demo happens, we'll still talk. So you've got to bear with us on that. So here's a demo showing you the operator right now doing this job for you. So yeah, again, the same steps. I'm just logging into my Azure credentials. If you have your own Kubernetes environment, you don't have to do the first 3 steps, because I'm just showing you the creation of a Kubernetes cluster and then getting the credentials so I can connect using kubectl. This is the same thing. The first 4 steps are the same that we did in the manual deployment. The change that you're going to see here, I'm not going to define storage because operator is going to do that for me. I'm not going to define how big or how small the instances are, because I can do all of that through the operators deploy YAML. Config map is your MS SQL configuration. If I have to give you a SQL Server configuration manager on Windows, that's your MS SQL config on Linux. where you can configure what port you want to listen to, what are the trace flags you want to turn on, always on availability group, agent, SQL Server agent, all of that configurations can be done here. And again, I'm creating the DXC because I want the clustering. I want high availability. So what am I doing in this demo? I'm deploying multiple SQL Server instances, connecting them on always on availability group on a Kubernetes cluster, correct? So that's what basically is happening. So all of the licensing details for DXC and the SA password for SQL Server is a secret that I've stored. Downloading the operator locally. Once I have the operator downloaded, you can see DX operator YAML, I have this. I don't have to touch this YAML file at all. All I'm going to do now is apply this operator. It creates the custom resource that he was talking about. The custom resource creation has happened. By the way, this is not running on 1x or 2x speed. This is exactly how fast things happen. So this is now connected. Now I'm deploying SQL. Now look at the YAML file for SQL Server. It's more like an expression. I'm just defining environment variables. So when this is getting created, I'll just show you the, I hope I'm showing the deploy SQL YAML soon. So I'm just showing you the instance being created. So you can see here, scroll up. Yeah, you'll see 3 SQL Server instances being deployed. These are 3 independent SQL Server instances being deployed. And why did it deploy 3? Because I said I need an always-on availability group with 3 synchronous replicas. That's what I mentioned there. And I can also say, do I need a contained availability group, a normal availability group? I can also define whether I just need a read scale availability group where I don't want high availability, I just want the read scale options to be there. All of that can be defined. Here is the image file for DXC. And as you can see, the DXC related configurations, and here is the SQL Server related image file. So I'm using the latest, which is SQL 22. The version, so my definitions are very simply, and also I've defined the limits over there. For example, I want the container to only use 2 CPUs and let's say 8 GB of memory, or as many CPUs as you want to give it. Once I do that, you have the SQL Server up and running. It took about 71 seconds for this to be up and running. So 71 seconds, 3 SQL Server instances deployed, always on availability group configured, and external services created so that you can connect from outside the Kubernetes service. So from my local laptop, I am just running SSMS, connecting to the SQL Server instance, expanding the availability group. There you go. You have the availability group. And I can just use this like any other SQL Server availability group. This is yellow. Why? Because I've still not added database to it. As soon as I add a database here, you would notice I'll just create a database, empty database. I'm just going to go ahead and create that, add to the always-on availability group, and it's going to be green. So I cannot catch up with the speed of my talking. Is still not matching up with the speed that things are happening behind. So that's the agility that we are talking here about. And all of this is fully supported. So as soon as this is done, you show the AG again, and once you refresh this, there you go. Everything is connected, working. OK, it should turn green. Yeah, everything is connected and working here. That's how quick things are with operator. So you've seen the manual deployment. You've seen the operator deployment. Now coming to the climax. The biggest demo that we want to show you, where all of this was still happening in one single place, right? I used an Azure Kubernetes service. I deployed SQL Server containers on that same Azure Kubernetes service. The first one was a manual deployment, not big deal. The next demo, which I'm going to ask OJ to drive, is where he's going to show you how you can deploy 3 disconnected environments, right? You have one on-prem, one Azure, one third-party public cloud, whichever you would want to do, and you can have containers running from one box to the other in same availability groups. OJ, over to you. Take us through that demo. So now this is the final demo that we want to focus on, and we'll go slow on this. If you have questions, stop us, ask us.
Yep.
But this is the final demo where we want to show you how you can connect without firewalls, without port configurations. In the entire demo, you will not see us go to any portal, be it Azure portal, be it third-party portal. We are all doing this from our Visual Studio Code using kubectl. That's all that we are going to show you. So with that, oh, you didn't have the demo? Or you do? I'm joking. We do have the demo.
No demos. Sorry.
So this is the environment. Let's just play this. This is the environment, one on GKE, EKS, and AKS. I love Azure.
Well, as I promised earlier in the talk, the Enterprise can run on any platform and any environment. So with that said, here we simply deploying our...
Let me zoom in.
Yeah. Oh, yeah. I can do it without looking at it. So first thing we want to do is to deploy our AG in AKS. Just what the Amit showed earlier, really all you have to do is download the X operator YAML, execute it to deploy it into the Kubernetes cluster, and then you define your AG quorum or environment, essentially. In this case, we simply say, I want a single synchronous replica and one async replica. And you're going to be asking me, why am I doing one of each? Well, what is the limit for the number of sync replica in an AG quorum, or a recommended limit, I should say? Anybody know? 5. Maximum of 5 sync and a total of 9 replicas. Okay, so because we are doing a cross-site and a lot of environments, make it a little more interesting to make sure that we don't over the limit, right? So that we break the SQL Server itself. So here we just simply create one sync replica and one async replica and deploy it into AKS. And as before, you deployed the operator, and then you deployed, or you applied, really, the SQL Server the deployment on AKS cluster. And it's what takes seconds, really, for all of that to happen and done. So once we have that, obviously, to connect another group into the stack, you got to tell the cluster, I mean the enterprise itself, how to allow another third party, another third node into the group. So then what you do, you create a one-time passkey. So this one, that's exactly what it's really for, one-time use. And you can set the time.
One-time passkey, sorry to interrupt. Yep. One-time passkey is step number 4. Yep. I'm unable to zoom, and thank you, OJ, for doing all of this in dark mode. This is why I don't like dark mode. See, the demos that I created had everything in white, which is visible. Sorry, go ahead. So here he's just showing the deployment YAMLs that you have. So there's nothing specifically new. This is exactly what we did with an operator in the previous demo. So when we go back, the OTP or the key, that one-time pass key that he's talking about, is coming up in the next step. Just give us 1 minute, and it'll be here. So
we come down to, you need a key to allow another node, another replica to join securely and privately, right? You don't want any replica to suddenly join into your cluster and take your data. So one-time passkey is there to allow you to extend this quorum, this AG quorum, bigger. So you create a one-time passkey from your AKS cluster. You need that, and then you will specify that for your next deployment. And for the next deployment, we're going to do it in GKE, that's Google Cloud. Similarly, how you do it in AKS. You download the operator YAML, applied it, and then also modified your deployment, SQL Server AG deployment YAML to give it the data that you want. In this case, once again, is a single sync and a single async replica. And so that's all you have to do in your deployment YAML. And then with that, apply that YAML against your GKE cluster. And really within a few seconds, They will find each other's and join into a single quorum. So the ability to extend your AG quorum remotely and securely is really that simple.
And is that one-time key pass valid for lifelong?
Nope. There is expiration on it. By default, it's good for 1 hour, but you can change that and modify it or set it to whatever time and date to your liking. So it is a configurable value. That's what I mean. One-time passkey. Once the time expires, that key is no longer valid. That means it's no longer accept any new member into the quorum. Okay. So which step are we on right now?
We are now deploying SQL Server on
GKE.
GKE. Okay, it's slow.
Oh. I'm faster than the machine. Come on. So hopefully we get to the part where we actually see how we actually play there. Some of the sample of the YAML, and it's exactly the same. The YAML, the deployment YAML is exactly the same, whether you do it on AKS, on-prem, GKE, EKS, doesn't really matter. The deployment YAML is simply your configurations for AG deployment. And the operator will take that, the data, and will execute it on your behalf, right? So if you define, say, 5 synchronous replica, it will go out and create 5 synchronous pod or replica for you. And have you seen in any point in time that we have to deal with the search at all by hand? None. Operator will do all of that for you. It manages your cert and ensure that the replica join into each other.
So this portal that you're looking at is a portal from DH2I called as the DX admin.
Yep.
This is just showing you that we now have 2 nodes, AKS. We just added the 3rd node, GKE, which is in red. And this 3rd node is actually a container running in GKE, and it's getting added to the availability group. You can actually use this tool as well to manage your availability group, where you can just move the database that is part of this AG from AKS to GKE. And nowhere, like what OJ was alluding to, nowhere did we open the portal, nowhere did we open a firewall, nowhere did we do anything. We just installed all of this through Kubernetes, through kubectl. So you didn't have to go to any other IDE or anything as such. And you were able to configure this. And now, after GKE, they're also probably going to add the EKS node as well. So that's exactly what is happening here. And by the end, you'll see all 6 replicas, 2 from AKS, 2 from GKE, and 2 from EKS, all added here. So that's exactly what is happening at this point of time.
So the step really to do it is the same, right? Whether you deploy it on-prem, in fact, you can. You create your own cube, the cluster in-house, K3S, whatever you want, in-house, and download the operator, deploy the operator, modify the deployment YAML to your liking, and kubectl applied, and you're done. So technically speaking, it's only 2 steps.
There you go.
Yes.
Every node from all the different worlds that you can have added to your always-on availability group. You can now move this database based on your requirement from one environment to the other.
Yeah. I'm sorry, would you go ahead? Do you have a question?
Is this, Windows clusters, you have multi-subnet cluster. Is this a multi-subnet cluster?
Is this a?
Multi-subnet.
This is
Absolutely.
Is this a multi-subnet cluster?
Absolutely. If you notice, it's a cross-cloud environment.
Yes.
So if it can cross cloud, can it not cross subnet? Of course, easily, right? Cloud is a lot harder because with cloud, normally you would have a VPN or some dedicated pipe or open ports to allow them to connect and communicate and transfer data. We create this tunnel dynamically on your behalf and allow the node to talk to each other. When I say a node, I'm talking about the replica here. They talk to each other and only open the port needed dynamically to allow SQL AG to do its job. That's it.
So listeners have multiple IP
What was that?
Yes, no, has multiple IP addresses.
Absolutely.
Yes.
That's your configurations.
Yes.
You can apply as many services as you see fit.
And
To the
you
environment.
and all the Kubernetes rules apply for SQL Server as well. For example, I want to expose, let's say, 5022. For example, for this case, 5022 was the endpoint mirroring endpoint for the always on. We were able to expose that. We were able to expose the SQL Server endpoints. You want to change the default port from 1433. You can do everything that you would normally do with your SQL Server that's running currently in production. In fact, if you want to upgrade some containers which are running, let's say you want to now bring in the CU17 when it is released, you want to do an upgrade, you can do a rolling upgrade following the same Kubernetes standard practice where you can start with the secondary, and once the replica, both the secondary replicas are done, only then the primary is done after the failover. All of that works perfectly well with SQL Server containers running on Kubernetes as well.
I have a question back there. Sure. Yes,
Yes.
it is. It's set up by default. It's all about it. Actually depends on you, right? By default, the operator will set it's your auto setting, but you can prep your data.
If you want to
ahead of
prep
time.
it, you could
You
just
attach it.
attach it, and you could leave automatic. So you can, the operator is completely configurable. So you can just say, I don't want auto seeding. I just want my secondaries are prepped. I just want you to connect.
And remember, with the operator, you can also, actually, with the sidecar model that we deploy here, you can add extra data or custom data to the pod, right? You can define that. And you can also attach external, what I call external volumes that have your own data on it, and then through script, whatever, that may be executed thereafter. So all of the things that you've done before, still there and available to you. Really, what you're seeing here is the ability to quickly bring your AG together into a single quorum so that you say, go my migrations, one of the best use case for that, right? I want to go, say, from Windows node into Linux, into containers for that matters. And here, simply making your Windows node, the Windows replica, the primary. When the data is replicated over, fail over onto whatever that may be, Linux or inside container, make that the primary, then you can remove your Windows node from the stack. So you're actually using this method to do migrations. Or you can use it as a DR, right?
Yeah.
So something happened, then the engine, the enterprise itself, will take care of the failover on your behalf.
Please. There's a question. So let me answer the SQL Server licensing because I am supposed to know SQL Server licensing. So the SQL Server licenses that you've purchased for Windows, that your company must have for Windows, that same licensing works for Linux as well. So there's no separate SQL Server license for Linux. The licenses, in fact, the unlimited virtualization that you get with SQL Server enterprise licenses with software assurance, that works for Linux as well. For SQL 22, when SQL 22 was released, we had something called as unlimited containerization just for the Linux perspective because we know customers are using this and we wanted to give the unlimited virtualization benefits there as well. So SQL Server licensing is practically the same. There's no difference. The SKUs are practically the same, no difference. You have the standard, you have the enterprise, all of developer, all of that SKUs are available on SQL Server on Linux. For DH2I,
For DH2I, it's licensed at the core level of your worker nodes.
You're saying this as a bad thing.
Nope. You got a single license for everything. So you get the operator itself, and of course, the ability to support SQL AG with the operator, and the tunneling technology that also get built into it. So that all in a single license.
You also have a developer license. So let's say you want to go get started with this without being bothered by licensing. because I do that for all my demos. I have a developer license signed up with DH2I. You can also do that. That's the last link for you to get that license, the developer license. And of course, just download any container image for SQL Server that you would want to work with. And when you deploy, all you've got to do is just say, what is this queue that you want to run? So I'm assuming because you're a developer, you would run a developer edition at that point of time. And you have an environment with all the features enabled.
Yep.
You can all try this right away as soon as you go back. Yeah.
So I'm just trying to understand the whole tunneling thing, right? Because if you have a virtual private cloud, provider A, virtual private cloud, provider B, the whole purpose of it being is to make sure that your network aren't getting there. So is that the technology in essence that for whatever the particular provider is, it is the things that you would have to do is happening, it's just doing it on your behalf?
Yes, and very interesting questions. That's two answers to that. First, in order for site A to connect to site B, there's got to be a way for them to go out and meet somewhere, right? And if you put everything behind the private network and you allow no going out whatsoever, there's no way, it doesn't matter what we do, we can't get out, period. So if, in that case, you can do port forward. Then you're going to say, right, this node can go out on this port. Remember, what's interesting about our tunneling here is about outgoing port and not incoming port. Most of the time when you're dealing with firewall, you are protecting the incoming. Here, it's all about going out. And if you can go out on a particular port, and if they all can go out and meet up with our, what they call a matchmaker, so we actually have a cloud service for that. It's simply there to introduce the peers, the nodes together. That's always there for, so if they can go out to our matchmaker somehow, merely still allow an outgoing port, so that the app can go out, and they can get to our matchmaker, then we would do the matchmaking and come back in on the same outgoing port.
And a quick follow-up question to that.
Sure.
Can that matchmaker service be running inside my network instead of running outside? Can that happen?
Yes.
Yeah, you copy those 3 files, right?
Which one?
The,
The MS SQL, the second, third slide,
yeah, early on you said that when you're setting up
Active Directory?
Active Directory, yeah, you generate those files and you copy them.
Yeah.
And they can be put somewhere else and it's to work, right?
Yeah. So those were Active Directory related files.
Yep.
That is completely independent of the DH2I, because you can always have a standalone SQL Server container instance, and you can have an Active Directory configured. For Active Directory to work on Linux, or for Windows Active Directory authentication to work on Linux, you don't have NTLM. We only fall back on Kerberos. And Kerberos works on Linux with key tabs and with SPNs. So those files were related to key tabs and SPNs. You could just copy those files anywhere you want internally. I think the question here was more about the DH2I, when it creates that OT one-time password key, when it creates that key, how does that key come from? For example, there has to be some way for 2 services to go out and talk at a common place. And that's what OJ was talking about, that this matchmaking service can be that common service, which can be internal or external to your network.
That is correct. Yes.
Okay. So let's talk about Windows upgrade process. If something goes wrong and you want to go back for SQL Server on Windows, you know you need to run the setup.exe and then run the entire thing. It takes about, at least from my support days, if I remember it right, it at least takes about 15 minutes when everything goes well. If
When
something
everything
goes
well.
yeah, then there is a different thing for that. But in this case, you're only using images. Remember, you're just using images. So I was working with CU16. Now all of a sudden I remember, no, I had to test this, let's say on CU14. So what I'm going to do is I'm just going to drop that instance and create another. Remember, when I do a drop instance, because I have a persistent volume, the databases are still there. I'm just saying, instead of using CU16 image, now go use CU14. So in 5 seconds, I am dropping, so I'm just running if I have to give you commands, kubectl, delete pod, whatever the pod was, kubectl, and then I'll run a command to ensure that the latest image, so in the SQL deployment YAML or in the operator, I will say, now use CU14 image. And the next command is, I don't even have to run the next command, because as soon as it drops, Replica understands it needs to bring up, and it'll just bring up. And now it'll be CU14.
But it's the same thing, actually. If we were to update the operator itself, then it's simply pointing to a different tag.
So instead of pointing to,
Oh, same thing. You can just specify the tag, and we will.
yeah, the system, so that runs the upgrade script. So when the SQL Server understands that you've gone from CU14 to CU16, or let's say CU 2019 to CU22, it runs an upgrade script, right, for the system databases. That same thing will happen here as well. So the time it takes for it to run that upgrade script, that is not going to change. So if it takes about 100 seconds for the upgrade scripts to run, that's still going to happen. But point is, all that EXE that you were working with, binary patching, binary laying, all of that is gone, because it's just an image at the end of the day that you're just pointing to. Yeah?
Is it then master is on its own image, the system database is on a separate?
No. The entire upgrade, all the upgrade scripts that you would have for an upgrade that happens, does happen in the case of containers as well. So if you have had the persistent storage where the master was there, the master will go through the upgrade script, the MSDB will go through the upgrade scripts, replication scripts will be run, all of that will happen.
But master, MSDB, all those aren't part of the image we pull down from the registry, right?
They are. Yeah, so if you look at this total size of the SQL Server container image, it's about 1.5, which also includes the system databases.
So if I need to deploy users or stuff to the master, is that, do I have to script that after I do my deployment? I'm spinning up a bunch of replicas, now I have to go out.
All the user data that sit inside the master database will retain throughout the life of your data, your PVC. It does not change. Just like how you have it today, right? When you upgrade an instance of SQL Server, user logins and all of that stuff inside master retain.
Right, I'm just saying, like, if I went backwards from like CU.
Oh, no. That would remain the same.
Yeah, but the logins will still be there because it's the same master. The master database files are still the same. So the logins will still be there. It's practically the same that's happening for Windows. Nothing changes there. So for example, let's say you created a login entry and a user, let's say a user as well, which is mapped to that login, and this user was inside the master database. Let's say you went from CU14 to CU17. Normal upgrade. So the upgrade scripts will run, the master will get upgraded, and you will see the logins, the users all there. You went from CU17 to CU14. The same stuff, what happens in Windows, the upgrade scripts that were run, those will derun, is that a word? I don't know. But then the same thing would happen there. So what happens in the case of upgrades? So think of upgrade as two steps. In the Windows world, you have the binaries that you lay and then the configurations that you run. In this case, the configurations will all be ran, or will all be happening, but what will not happen is the binaries and upgrading the binaries. All of that is completely not done. But if you have follow-up questions, more than happy to pick them.
The term you want is downgrade.
Downgrade, not derun. Thank you. Yeah, but you can scan this QR to get the operator, free trial, the developer
Absolutely.
version, to kind of get started. And thank you so much for staying.
Thank you.
And if
very
you have
much
any
for
questions, more than happy to
come
take
up
them
and talk to us or catch us at the booth. We'll be at either booth today and tomorrow.
Yes. Thank you.
Thank you, guys.